This paper contained total 4 questions from infinite series and total marks is 15. तो ये पेपर में से इनफाइनाइट सीरीज का ही वेटेज 15 मार्क्स का है. ओके, सो नाउ लेट्स डिस्कस ईच क्वेश्चन वन बाय वन. क्वेश्चन 1b, discuss the convergence of the series 1 upon 1 into 2 plus 1 upon 2 into 3 plus 1 upon 3 into 4 plus infinite. If convergent, find its sum. So now in this question, first we need to discuss the convergence of the series. मतलब कि हमें यहाँ पे ये चेक करना है कि गिवन सीरीज कन्वर्जेंट है या नहीं. एंड इफ द सीरीज इज कन्वर्जेंट, फाइंड इट्स सम. मतलब कि ये सीरीज का सम क्या है वो हमें फाइंड करना है. नाउ दिस क्वेश्चन कंटेन 4 मार्क्स. सो नाउ लेट्स स्टार्ट द सॉल्यूशन. फर्स्ट ऑफ ऑल, राइट द जनरल फॉर्म ऑफ दिस सीरीज. सो कैन वी राइट सीरीज n is 1 to infinity 1 upon n plus 1. Okay, so let's check. If I am putting n equal to 1, so what we get? 1 upon 1 into 1 plus 1 2. So 1 upon 1 into 2 plus, now put n equal to 2. So what we get? 1 upon 2 and here 2 plus 1 3 plus put n equal to 3. So what we get? 3 into 4. Okay, plus so on. So this is the general form of the given series. So first of all, we need to convert it into general form of the series. Now our objective is to find the convergence of this series. Okay, so now first, this is in a form of 1 upon n plus 1. So here 1 upon n, can we write 1 upon n square plus n? If you multiply by n, so n square plus n. So now this one is what? This one is the polynomial in L. Say yes or no. So if polynomial is given, then generally what we use? We can use comparison test. Say yes or no. सही है. If numerator or denominator contain polynomial in n, then we can use comparison test. Okay, but using comparison test we can find only convergent and divergent of the series. Say yes or no. हम सिर्फ ये बता सकते हैं कि सीरीज कन्वर्जेंट है या नहीं, लेकिन हम उसका सम फाइंड नहीं कर सकते. और यहाँ पे हमें क्वेश्चन में क्या पूछा है कि इफ सीरीज कन्वर्जेंट, फाइंड इट्स सम. Okay, so that's why here we are not using the comparison test. तो ये सम में हमें कन्वर्जेंस भी चेक करना है और सम भी फाइंड करना है. ओके, तो हम यहाँ पे कौन सी मेथड यूज करेंगे? हम यहाँ पे सम ऑफ फर्स्ट एंड टर्म Sn. ओके, ये मेथड हम यूज करेंगे. जनरली सम इज आस्क्ड. You can use Sn method or you can also use geometric series. लेकिन आप geometric series कब यूज कर सकते हैं? If ratio is given. Okay, but in this sum, in denominator polynomial is given. So here ratio is not fixed. Okay, so that's why here geometric test is not applicable. Okay, so we have only one choice, Sn method. Sn means sum of first n terms. Now what is the Sn method? In this method we have to find the sum of first n terms of the series. Now on this apply limit n tends to infinity. Okay, so now if this value is some finite number, then what we conclude? Then the series is convergent. Okay, and this limit value gives sum of the series. Now let's understand. Here what is Sn? Sn is sum of first n term. Now on it apply limit n tends to infinity. Means here we are finding sum for very large value of n. Okay. So that's why this is nothing but the sum of the entire series. Okay. Now if we get the answer either plus infinity or minus infinity, then what we conclude? The given series is divergent series. Okay. So now let's find the solution. First of all, this is the general form of the series. Okay. Now resolve into partial fraction. Can we write this one in this way? Say yes or no. So what is the value of this? Let's see. 1 upon n minus 1 upon n plus 1. Okay. Now take the LCM here. So what we get? Cross multiplication n plus 1. Here n plus 1 shift here and shift here. Okay. So we get n plus 1 minus n upon n plus 1. Okay. Now n is cancel out. So what we get? 1 upon n plus 1. Say yes or no. So here just we rewrite this 1 upon n plus 1 in this form. Now apply series. So this is my series n equal to 1 to infinity 1 upon n minus 1 upon n plus 1. I am just rewriting this in this form. Now find sum of first n terms. It is denoted by Sn. So that's why take series n is 1 to capital N. Here we are taking sum of first n terms of this. Okay. Now first put n equal to 1. So what we get? 1 minus 1 upon 2 plus put n equal to 2. So we get 1 upon 2 minus 1 upon 3. Put last term capital N. So what we get? 1 upon capital N minus 1 upon capital N plus 1. Okay. So now this is the sum of first n term of the given series. Now observe here minus 1 by 2 plus 1 by 2. So this term cancel out. Same way minus 1 by 3 plus 1 by 3 cancel out. Here this one plus 1 by n minus 1 by n cancel out. So observe this pattern. In this pattern only first term and last term remain as it is. In between all terms are cancel out. Okay. So that's why after cancellation of terms, what is the Sn? Sn is equal to 1 minus 1 upon n plus 1. Now apply limit on it. Okay. So what we get? Limit n tends to infinity Sn is equal to limit n tends to infinity 1 minus 1 upon n plus 1. On this apply limit on both the side. Okay. So 1 as it is, separate the limit. So 1 as it is. Here 1 upon infinity become 0. So this quantity become 0. So what is the answer? 1. Okay. So here limit n tends to infinity Sn is equal to what? We get some finite answer. So that's why what we conclude? The given series is convergent series. And this limiting value gives us the sum of the entire series. So what is the sum? Sum is 1. Okay. So using this method, we can find sum of the series as well as we can check the series is convergent or not. Okay. So that's why here we must use this Sn method. Okay. I hope you all should understand. Question 2a. Discuss the convergence of the series 2n plus 1 upon n plus 1 whole square. This question contain 3 marks. तो पहले हम ये देखेंगे कि ये सीरीज सॉल्व करने के लिए हमें कौन सा टेस्ट अप्लाई करना है. ओके. तो इसके लिए हमें क्या करना है? ये सीरीज की जो टर्म है इसकी पैटर्न को हम ऑब्जर्व करेंगे. So here in numerator 2n plus 1 is given. So this is what? Polynomial. Okay. Again here n plus 1 whole square. So This is again a polynomial. Okay. So if polynomial is given in numerator and denominator, we can use limit comparison test. Okay. तो लिमिट कंपैरिजन टेस्ट के लिए फर्स्ट ऑफ ऑल हमें क्या चाहिए? फॉर अ गिवन सीरीज ए एन वी नीड टू फाइंड अ न्यू सीरीज बी एन. ओके, सो दिस इज माई गिवन सीरीज ए एन. नाउ हाउ टू फाइंड बी एन? सो फॉर वेरी लार्ज वैल्यू ऑफ एन, हियर व्हाट इज गिवन? 2n plus 1 upon n square plus 2n plus 1. Now here square is given, so simplify this. So we will get n square plus 2n plus 1. So for very large value of n, this one is approximately equal to n upon n square. Can we write? And here 1n is cancelled out, so that's why this one is same as 1 upon n. Okay, so this is my new series Bn. But for quick decision, how to find Bn? So from numerator take the maximum power of n. So here what is the maximum power of n? 1. Okay, so that's why I write n. Also in numerator, what is the maximum power of n? N square. So write n square. Okay, now simplify this. So 1n is cancelled out. We have 1 upon n. Okay, so what is my Bn? My Bn series is 1 upon n. So generally Bn series is either what we have P series या फिर हम क्या ले सकते हैं? ज्योमेट्रिक सीरीज. ओके, तो P सीरीज होनी चाहिए या फिर क्या होना चाहिए? ज्योमेट्रिक सीरीज. तो ये हम क्यों कर रहे हैं? बिकॉज इसका कन्वर्जेंस क्या है हम इजीली फाइंड कर सकते हैं. ओके, सो दिस इज माई Bn सीरीज. नाउ नेक्स्ट स्टेप, for limit comparison test, what we need? We need to find one limit. Limit n tends to infinity an upon bn. Okay, so now find this limit. Limit n tends to infinity. What is my an? 2n plus 1 upon n plus 1 whole square, and bn is 1 upon n. Now simplify this. Do the cross multiplication. So what we get? N upon 1. 2n plus 1 upon n plus 1 whole square. Okay. Now from this term, take n common. So what we get? N into n become n square. 2 plus 1 upon n. Similarly, from n plus 1 whole square, take n common. Okay, so when we take n common, here square. So that's why we have n square. Okay, so n square is outside. 1 plus 1 upon n whole square. Now apply limit. This n square is cancelled out. And after applying limit n tends to infinity, this value becomes 0 and this value becomes 0. Okay, so what we get? 2 upon 1 square. So answer is 2. So 2 is what? Non-zero and finite limit. Okay, so as per the limit comparison test, what is the conclusion? Series an and series bn both converge or diverge together. Okay, तो पहले हमें ये मिल गया कि सीरीज an और bn दोनों क्या है? इसका कन्वर्जेंस क्या है? सेम है. If series Bn is convergent, then series An is convergent, and if series Bn is divergent, then series An is also divergent. Okay, तो ये हमें एक रिजल्ट मिल गया. अब हम क्या करेंगे? नेक्स्ट सीरीज Bn का कन्वर्जेंट फाइंड करेंगे. ओके, क्योंकि अगर सीरीज Bn कन्वर्जेंट है तो ये सीरीज भी कन्वर्जेंट होगी एज पर दिस रिजल्ट. ओके, सो दैट्स वाई नेक्स्ट check the convergence of the series Bn. So now what is the series Bn? Series Bn is series 1 upon n. Okay. Now this series is what? P series. What is the form of the P series? Series 1 upon n raised to p. Okay. So this is the P series. Now compare with P. Okay. So here what is P? P equal to 1. So now for P series, if P is greater than 1, then what is the conclusion? The series is convergent series. If P is less than or equal to 1, then the series is divergent series. Okay. So here what is P? P equal to 1. So hence it is divergent. So here what we conclude? From the limit comparison test, since series Bn is divergent series, from this what we can say? The series An is also divergent.